If you guys want to, I can just run through the PowerPoint for the skeletal muscular and just point out what I think is important. Got it. So I'll go ahead and open it up. Let me see how to share the screen. Got it. Can you guys see the screen?
Yeah, I'll monitor the chat for you too.
Got it. So yeah, musculoskeletal is pretty chill for physiology. You don't have to know too much in depth, like as anatomy. They care primarily just about the function, how it works, and just some basic concepts. So in regards to skeletal muscle, I'm gonna just run through this really quick and point out the things I think will be more important. So yeah, general way it functions is every motion is done by your brain, comes from the motor cortex, and then it follows these tracks, goes down the brainstem, and then there's these efferent fibers that go to your muscles and stimulate them. So the part that I think is most important is this end part right here, how it innervates. Wait, let me see. I see there's a question. Could you cover the diff troponin and how it's involved? Okay, yeah, so that's going to be a little bit more important. But as I was saying, I want to go to that really quick. But yeah, the main part is just end part right here, how the nerve stimulates the muscle, how the signal goes through the fibers, and what causes the physical muscle contraction to happen. So in regards to that question about the troponin, I'm going to go ahead and to the slide. I'll go actually over this slide. This is the highest yield slide. And then it's regarding the order that a muscle contraction occurs. So yeah, with any other thing in the body, any movement, thought, idea, all requires action potential. It's the way that your brain communicates to the rest of your body. So from the brain, the action potential travels to the muscle, to these structures called T-tubules. So along the fiber, right here, you see that there's these long fibers for your muscles. The T-tubules are these uh kind of like these columns that go down each fiber. And as the action potential moves down, it allows it to communicate with each of these fibers. So it's a way of relaying the signals down the muscle and causing the contraction to occur. So the really important thing to know about this is the order that it happens. It starts with the potential, travels down the T-tubule, and then these receptors, you have to know the specific order. I remember there's a question specifically about it. It starts with the dihydropyridine and then follows with the ryanodine receptors. And then the ryanodine receptors are the ones that physically tell the sarcoplasmic reticulum to release calcium. And then calcium is what interacts with the troponin and then causes the muscle contraction. So this is the pre event that is required in order for a muscle contraction to happen in anywhere in general. So yeah, this one is first dihydropyridine. It's the receptor in the T-tubule that allows the action potential to propagate. And ryanodine is the inside of the sarcoplasmic reticulum. This is where your calcium is stored and actually causes the calcium to be released and cause the muscle contraction. So general structure of how the muscle works. You have a thick filament myosin and thin actin filament as well. They're arranged in a parallel fashion like this. So what causes your muscle to shorten is those fibers sliding across each other like this. So when you do this, the muscle gets like smaller, right? And that's causing contraction to occur. So flexion, extension, they're in opposite direction, but it's the same thing. The strands are just getting tighter, pulling on your bone and causing the joint to move. So yeah, once it's contracted, it gets tighter like this and it'll get smaller. So in regards to that question earlier with the troponin, this is how it's arranged. So on top of your myosin, the thick band we saw from earlier, there are these proteins that are wrapped around it that are kind of regulating how the motion occurs. So at resting state, there's this long fiber called tropomyosin, and it's covering the actin binding sites. So it's preventing the actin from binding onto myosin and causing that contraction from occurring. So this is how all muscle is at rest. And there's also this protein called troponin that has three subunits right here, the C, I, and T. C for calcium, it's the calcium binding site. I for inhibitory, it's the part that covers the head, so inhibits movement. And T, the part this stands for tropomyosin. It connects to the tropomyosin strand, which is blocking all the binding sites. So what happens is that calcium will bind onto the C terminal of the troponin, and then it'll cause it to slide out of the way. So this is all covered. Once calcium binds onto troponin, the tropomyosin will shift and then allow the actin heads to connect and then cause contraction. So let me look at the slide where it shows them interacting right here. So this is another really important order thing. It's kind of a little bit counterintuitive. That's why they like to ask questions about it. But basically, when ATP is bound, the first step is the calcium binds onto troponin. It releases the tropomyosin from the binding site. Actin is able to attach. So when you have ATP, ATP will bind onto the myosin head, the head right here, the myosin head, and then cause it to detach. So it's like a little hook along the fiber. When ATP binds, it detaches, and then it's gonna want to stretch out its little arms. So it's gonna stretch out. ATP is split, and then it's gonna reconnect. So it's gonna stretch and reconnect at a farther location. And then once it's reconnected, it's gonna pull its arm back in. So it's gonna go like this, reconnect, and then when the ATP is released, that initiates the power stroke. So it's gonna go like this. So along all these fibers, there's a lot of these heads that are attaching and reattaching, and when it reattaches, it causes the power stroke to occur. So when it occurs, it's going to cause a sliding across. The contraction will cause the muscle to get tight, and contraction will occur. So yeah, the main point is to know the order of this, to know that ATP detaches the myosin head from the actin, and also that when the ADP is released, it leads to the power stroke. So those are pretty important things to know. So the most important thing for the muscle unit is just knowing the order. So this is a good summary of everything that happens. To reiterate, action potential comes, goes down the T tubules, and then there's the DHP dihydro, I forgot the thing, DHP, and then the ryanodine receptors that causes release of calcium. Calcium binds to troponin C. Calcium causes troponin to move tropomyosin out of the way for the myosin binding heads. Myosin binds to actin, cross bridge forms. ATP binds, myosin detaches when ATP binds. That's the important distinction. They might ask that. ATP is hydrolyzed. It stretches its arms out to get cocked, and then when it's detached, the power stroke will occur, and then it's a cycle. It goes like that over and over, and that's what pulls the fiber together, and then contraction. So yeah, so order is very, very important. That's one of the main things that they can pretty much ask on. And for this test, there's very few physio questions. So if there are any, it'll be mostly on this. And another thing I remember that was more important and higher yield was the name of the regions of the muscle fiber. Let me find a good one. Good slide for you guys.
I feel like they like to ask about that on Histo too. So
Yeah,
it's good to know.
yeah. For histo, it's extremely high yield. So let me just find a good. It's probably too high. Yeah, right here. So there's different zones that they like to classify along the muscle fiber. And then the only thing they can really ask you is like when contraction happens, what will happen to these zones? So some specific ones are like the A band. This is where the myosin is, right? All this purple stuff. So during a muscle contraction, the myosin and actin strands aren't themselves physically contract like getting shorter. It's them when they're like expanded in the resting state, they're just pulled apart farther. And then it's the sliding together that causes the length of the fiber to shorten. So the A band is just the area that the myosin is situated in. And then the I band is where the empty space is before a contraction occurs. So when contraction occurs, this I band will disappear. That's something that they could ask, like during contraction, which zone will disappear? Another thing, yeah, and then like M line is just these kind of like scaffolding of the myosin. So this doesn't move. This is just like a supporting structure. Let me see. Yeah, Z disc is just the border between each one of these myofibrils. So this is like one unit. So the Z disc is like the edges of it. And yeah, the H zone is also where it will slide across. But yeah, that's basically all of the regions. But I think the most important thing they would ask to be like which one contains the myosin. It would be the A band. Which one will disappear during a contraction? That could be like the H zone or the I band. But other than that, the rest is not too important. They just care more that you get the basic concept and the order specifically of how contraction occurs.
I would also just add on to what Andrew said, in regard to the Z discs. They could also ask you a question about how those are physically moving closer together during a contraction, because they're marking like the ends of two different sarcomers, and so they are getting closer when there is a contraction that occurs.
Yeah, so basically all the stuff where there isn't purple will be contracted. So this Z disc will physically get shorter. And then it's that shortening that causes the muscle to get shorter, and then you contract to move your arm. Yeah, so good point by Quinn.
And I'll also throw in another thing to add on to what Andrew said about some of the essentially the few different topics that he's already talked about that are like I agree with that are all extremely high yield. If they gave you, which I'm assuming they did, copies of first aid, and you go to the skeletal section, it's like 459 in my edition. It might be slightly off for your guys. The like end plate action potential, cross cycling, and sarcomer are all on one page, all on a really good illustration with all the steps listed down the side. So if those are, they didn't give you guys a copy of first aid. Okay, they should at least have given you guys access to the electronic version.
It might be in the
And
library. Let me see.
yeah, page number. So I have the 2024 edition, and it's 459 is the exact page. It varies depending on which edition you have, but you could also definitely check the online version because I don't know why they wouldn't provide that one to you guys. But this, I just like that I'm very much a visual learner, so I just wanted to throw that out there for anyone else who also likes very clear, color coordinated pictures.
Someone said so Z disc, H zone, and I band all decrease. So I band, H band, H zone will decrease in the contraction because it's where they're not overlapping. The Z disc is more of like this it's kind of like the border of the fibers. So they will get closer together, but this like the tall length won't change. It's just they will get closer together is what they might say. Will we have access to these slides? Oh yeah, these are all on Canvas. So it's just the probably the like the online videos with the I forgot the guy's professor name, the Harlem professor, Conrad. These are his slides, so I was just going through them. But honestly, for Conrad's slide, I feel like a lot of these are kind of random and like not very important for the actual exam. I was just skipping over the not as important stuff and talking more about like the things that they would probably ask.
I
And
feel
then
like the lecture slides that Dr. Kaur and Dr. Shaw give you are more focused and will be mostly what's tested on. Last year, I didn't even pay attention to Dr. Fisher's slides.
yeah,
I
I
just
didn't
gave
even watch his lectures. I think they're not like a good use of time as much as like Core's and Shaw's slides. But honestly, the best one is to look at Costanza. Costanza will be more than enough for most of the units. study this. Yeah, I used study this when I was didn't want to physically read, and then I would probably read Costanza after study this just to get the basics down. But for physio, you don't really have to memorize as much as anatomy. You just have to be able to like picture it and then like understand it really well. And they'll just ask iterations of the question of the concept. And I think the most helpful thing is to do a lot of TA reviews because a lot of the questions basically they like kind of remember stuff from the test and they might ask that. And there's going to be a lot of iterations of the same concepts, so you can get a lot of reps in until you like get it really good, you know. I think there was something else.
The
Oh, there's
pictures out
another.
of
Yeah.
Costanzo. Oh, sorry, Andrew.
Oh, yeah. Any diagram in Costanza is extremely high yield. Like they test almost every diagram. So especially for like cardio and like other units too. If you ever see a chart or a graph or anything depicting something, you always have to like understand it really well because it's such an easy question for them to ask, you know. And yeah, you can go, Quinn. Sorry about that.
You said exactly what I was going to say. They love to just look at a picture from Costanzo and then be like, okay, what test questions can we write based off of this picture? And so, like, if you understand those charts, you'll be able to pick out those questions really easily, and they'll be pretty straightforward to you.
This is one single point that if they can also ask about. So yeah, this is just a visual representation. This is the T tubule. It's going down perpendicular to the muscle fibers. This allows the signal to penetrate the muscle fiber. The DHP or DHP receptor is the one that allows calcium penetrate. The ryanodine receptors is connected to the sarcoplasmic reticulum and then causes calcium to come out attached to troponin and cause muscle contraction. And then another important thing is like how do you have the store of calcium, right? Because in order to release calcium, you have to store it up first, and then that takes energy. So there's going to be a ATP pump. It's a CA ATP pump on your sarcoplasmic reticulum. So during rest, like after contraction, this pump is constantly at work, pumping it back into this to prepare for the next contraction. So very similar to like the NAK pump in your neurons, but this is for muscle specifically. It moves calcium in the SR, and then there's these proteins called calsequestrin that binds calcium in the inside the sarcoplasmic reticulum, and then this way it'll decrease the workload for it and also create a storage for calcium to be released once another action potential comes down the fiber. Yeah, this for sure will be a question, I think. I don't want to say for sure, but yeah, I recognize it, so that's why I mentioned it. Yeah. This list extremely important. I would know muscle contraction by heart, especially because it's easy to mix some stuff up. And I remember in regards to tension, I don't remember what class this was for. It might have not even been physio, but I remember that in order to generate the most force in a contraction, when your arm is fully outstretched, it's harder to generate strength because the crossing between the actin and myosin is very minimal when it's fully outstretched. So once you have like halfway, like your arm is half bent, when there's more surface contact between the actin and myosin, it's easier to generate that initial force to move to move like a weight or something. So like let's say you're doing a bicep curl, it's harder to do it when your arm is fully outstretched compared to when it's already half bent. So yeah, that was a important concept. Yeah, like what he said, optimal length.
I agree with Olivia. This was definitely a question last year as well.
Yeah.
I'll plug another outside resource here and say that sometimes I love Sketchy. Sometimes it's physio videos are hit or miss depending on them, but the one on length tension relationship is really good. Very simple picture, not a lot going on. So if you like that as a learning method, I would recommend that one because I had trouble with this topic because it was literally so boring that I didn't want to learn it. But
Yeah, but I think very high yield for sure is the order of muscle contraction and also like calsequestrin, the ATP pump in the SR. What else? Like tropomyosin, troponin, how that functions. Oh yes, drugs. Drugs is another one. I did not see it in these slides, but yes, there are drugs that can inhibit help with muscle contraction. The list, I believe there were five. There is, ooh, I don't want to tell you the wrong info, so it's better for me to look it up.
No, I did this part of the TA review. But yeah,
Oh,
it's
so you
Botox,
got,
curare, neostigmine, pyridostigmine, and hemicillinum. Botox I think is pretty high yield for this one. Is it
Circa and sarcoplasmic is the same thing, I believe. Let me just make sure.
yeah, it's the same.
They're the same thing. They just like to give it an acronym for funsies. But yeah, let me write it down. It was botulinum, hemicollinium. I feel like digoxin might make a little.
Sorry,
I
I'm
don't think
gonna
they've done that
just
yet.
Okay.
clarify on the Circa thing. So Circa specifically, when they're saying that is, yeah, exactly. They're referring to the calcium channel ATPase that is pumping
Oh, yes,
calcium.
yes. This little thingy. Where did it go? This little thingy. Circa.
Yeah, so so that's that channel is the Circa pump going in back and pumping calcium back into the sarcoplasmic reticulum.
Yeah. And calsequestrin is just protein that it's like here and it helps bind calcium. So the it doesn't have to work as hard to gather the calcium from outside.
Yeah. So
So it
once
binds
the
and then
calcium's in there, it keeps calcium basically keeps the calcium inside instead of letting it like leave through a different calcium channels because there's still like diffusion channels in there. So you don't want all of the calcium that they just work to pump in to get out. So that's all the calcium does.
yeah, it's like a little sponge for calcium. Yeah,
Yeah.
wait. I think I'm gonna write down all the drugs just so they have a list of it. It was botulinum,
hmm
hemicollinium. What were the other ones again?
Curare
Oh
and
yeah,
then
curare.
neostigmine. And I think Doritos did mean, but
Yeah,
they're
I see it
basically
on
the
the list here.
same.
I see acetylcholine, atropine, neostigmine, pyridostigmine, Botox, and curare.
All right. If I missed something, can you help put it in? Yeah, but in regards to these drugs, it's just memorizing. But yeah, like Alan is helping say, these are what they do. Hey, good work, Alan. I would fact check because this is pure memorization, right? So then I can it's
No,
best to
but I'm
know.
pretty sure everything you wrote is right. So,
Let me see. Botox prevents ACH release. Yeah, that sounds right. Curare competitively binds catenic receptors. Yes. Neostigmine inhibits ACH. Prevents reuptake. Yes. I just don't remember neostigmine. Oh no, inhibits ACH. Yeah, yeah. So yeah, these are all right. But basically, just in the broad scheme of things to help with understanding, these drugs just interfere with either so when let's say like an action potential reaches the axon terminal, right, of a presynaptic neuron. What occurs is that that neuron, if it's specifically for like a muscle fiber, right, it's going to release acetylcholine, and that's a neurotransmitter that's associated with like muscle contraction and nicotinic receptors. So anything that will disrupt the binding or the availability of acetylcholine will lead to these like pharmaceutical effects. So either you mess with the release of acetylcholine, the binding of acetylcholine, or the breakdown and reuptake of acetylcholine will all affect how long it's in the space of the synapse or how much is released in the synapse. So it's best to like have a visual, kind of like pre and post, and then have like little arrows drawing to where each of these drugs are interacting just to be able to picture it. So like I'm just going to go off of what Alan said. So Botox preventing acetylcholine release will allow acetylcholine to not be released, and that way you're going to prevent like over sensitivity of the neuron, right? So you're not like it's not always like releasing on accident and then causing contraction. And like other ones like curare competitively binds to nicotinic receptors. This is better like if you this is also like an inhibitor, right? You're competitively binding, blocking the receptors from acetylcholine to bind. So similar function just at a different point in the pathway. Neostigmine inhibits ACHE. So acetylcholinesterase breaks down acetylcholine, and then that's reuptake into the neuron to be recycled. But if you prevent the breakdown, acetylcholine will stay in the synapse longer and help promote action potential. So you'll be able to like contract easier. And same with hemicholinum prevents reuptake of choline. This is going to deplete the acetylcholine supply in your body, and then it'll be kind of inhibit. So this is going to be an inhibitor as well. Thank you, Alan. If you want a
Mhm.
TA position, you should ask Dr. Kaur. She'll be happy to have you there. But
I
yeah,
think you guys also have to know the mechanism of botulinism. Correct me if I'm wrong. Oh, master student. Oh, good job. Um, but for
it'll be
that one,
2 good years though.
yeah, that one causes like spastic paralysis because it's preventing the inhibitory signals from being released. So like your GABA is no longer being released. So since you're not having that inhibitory reaction, your muscles are only being stimulated. So that's why you get the spasticity.
Yes. And then if you guys want us, so this is basically most of what you need to know for muscle. It's very chill for physio because in previous years it was just a small component of a larger test, right? So there's not too much they can ask, and I don't believe physio is even too big of a component on this mod. So other than what we said, I don't really remember them asking anything other than that. But I don't want to say false information, but that's as much as me, Olivia, or Quinn can remember that is important. If you guys have any other questions about like the fluid compartments or action potential, you can ask as well, and we can go over it too. But Dr. Kaur said that they won't focus on it as much, but I think you guys should still know it. So if you have any questions, you should ask now too.
Yeah. That'll at the very least come back. So if you're having trouble with it, it'll be helpful to go through it sooner rather than later.
Yeah. I'm a action potential monster and osmosis monster as well. So if you guys need any conceptual understanding, feel free to ask too.
I don't remember there being um anything really with the force velocity
Yeah, not
relationship.
really.
I feel like that's pretty low yield.
Yeah, let me see what they even have on here. To be
Oh,
completely honest, since I don't even remember at all, I don't even remember what we learned about it. Let me see.
no, I feel like that is more OMM related, to be honest, in terms
Yeah,
of what you're lifting.
physio cares a lot more just like functionally, how does it work? And you should be good. Where we Yeah, this slide is kind of weird. It's just if it's heavy, it's hard to lift. Light, it's
Yeah,
easy to
no.
lift. Let me see, velocity. Yeah, so you lift faster if there's less preload, so less weight. She'll start giving you links.
Oh, I feel like the what they're getting at there is also just to deal with the like optimal length, with
Yeah,
getting to the right tension. But I think they're gonna ask more about what it means to be at like an optimal tension.
yeah. This chart's kind of dumb too. It's just saying
Yeah.
the heavier something is, the harder it is to move it. Yeah, more force, less speed. Yeah, these are like not too important. Stretched resistance and myelination. I don't believe they'll ask. that was more mod 1, but yes, with myelination, so things that affect an action potential, right? The velocity of it is the surface area of it, right? So it's like, got it. Multiple sclerosis, so it's autoimmune problem attacking the myelin on your axons. And this is associated to what Fatima asked too. The speed of an action potential is dependent on a few factors. One is the surface area, right? The bigger it is, less resistance it can go through. And there's two resistances going on. There's resistance within the circuit. So I'm going to talk in like electric terms because it's the same thing. If like the visco if the viscosity of the inside is high, like the resistance, then it's harder to propagate a signal. So that's like if you use like a copper wire versus like if it was rubber cords or something, right? Rubber has a high resistance, no signal will travel through. Copper is a good conductor, so it's going to go fast through the wire. So that's the resistance of inside the axon. But there's also resistance of the membrane. So you want high resistance of membrane because it'll be able to keep the charge within the wire. So that's why myelinization, it's like insulation of this wire that causes the charge to be held in and be propagated a lot easier. Another thing with the propagation thing is because along the axon where there's myelin, there's no channels, like the sodium channels that allow action potential to happen. So when depolarization happens along a myelinated axon, it only happens on the gaps between each myelination, like area of myelin. So that's called the node of Ranvier. That's where all the channels are, and that's the channels that get depolarized. And because of that, it has to hop along the myelin. So that's called saltatory conduction. And that speeds up the signal. So you're like, oh, there's less channels. It'd probably be slower, right? But no, no, no. Yeah, it'll jump across the myelin, and that actually makes it faster. So that's why myelination is better. So when you have multiple sclerosis, you're damaging all those myelin sheaths and messing with that insulation. So you're making the signals be harder to propagate along the axon. So you're going to have like some neurological deficits from that. Gravis. So gravis is also another autoimmune problem. Multiple sclerosis attacked the myelin sheath. Myasthenia gravis attacks the acetylcholine receptors on the postsynaptic neuron. So like we were saying earlier, let's say this is postsynaptic neuron, the receptors are messed up, right? So then when acetylcholine is released, there's less receptors to bind onto. So it's also going to mess with contraction because it's going to disrupt the signal between neurons. So a typical presentation of someone with myasthenia gravis is like in the morning they're okay, but as the day progresses, they get really tired. They're like very lethargic. They have ptosis, one of their eyes is lower. And that's because as the day goes on, the your neurons are like they're not functioning at full capacity, and it's going to like put a lot of strain on those neurons, and then you get the function will be worse and it'll be tired and yeah, basically that's it. So the treatment was the one that keeps the acetylcholine in the synapse. So when you increase the amount of acetylcholine in the synapse and you keep it there, you don't let it get reuptake, then it can help ameliorate, like make it feel a little bit better. So they'll be able to not be as tired at the end of the day. Yeah, it was neostigmine. Yeah.
Yeah, which
So
is
it
interesting that they
inhibits.
still teach that because it's no longer the first line.
Yeah,
But
they could also put pyridostigmine for this, but
yeah,
Yeah. So then, yeah, neostigmine, ACHE inhibitor, it inhibits the breakdown of acetylcholine, stays in the synapse. It can stay there to keep muscle contraction happening, and that's the treatment, at least in the past, and the ones they like to test a lot. There is also another stigmine, the one that they see the difference between myasthenia gravis and the other one. I forgot what it was called. Do you
multiple
remember?
sclerosis.
No, there's one where like they present similarly, and you need to do a test to see.
Lambert-Eaton.
Yeah, Lambert-Eaton versus myasthenia gravis. There's a drug you give that, depending on whether it helps or not, you can tell the difference. I don't know if it's on this unit. I just remember it exists.
I don't think it is.
I don't
Yeah,
think that was covered on this test. I don't remember
yeah.
what test, but
Okay, yeah. So if you don't need to know Lambert-Eaton, you don't have to know that drug. And then I don't have to look it up. Yeah. So yeah, they present very similarly. That's why it's hard to tell. But there's a drug that makes one better and one not better. So that's how you tell. But that's future stuff.
Yeah, eardrum
Yeah.
hernia.
Yeah, it's yeah.
Yeah, Jay Park, if you want to be a TA in the future as well, feel free to hit Dr. Core up. So there's
There was
another
a question,
question.
Andrew. I don't know if you saw about the myelin.
Yeah, why is decreasing velocity more would like decrease the diameter? So yes, the reason why myelin damaging the myelin, it's not only velocity, right? You're decreasing the ability for that charge to be held within the axon. And if you think about it, the axons that are myelinated in your body are the really, really long ones in your body. So the ones that go from your brainstem all the way down to like your spinal cord and uh yeah, the ones that are like traveling all the way down your spinal cord, right? So then it's not the problem that the velocity is decreased. It's more of a problem as the charge can't be held within the axon. So while it's going down like their long trek from the brain, it's going to kind of decrease the ability to propagate those signals down that axon. So the problem more is like the signal can't travel as effectively, and that will lead to like the deficits you would see in multiple sclerosis. And I don't believe there's a condition that decreases the diameter of a neuron, not that I know. And then I don't think we'll ever be, well, we won't be tested on it for sure too. But yeah, I don't have anything off the top of my head that presents in that way.
I would just think of like maybe in like aging atrophy of neurons, but honestly, there's don't worry about it.
Yeah,
It's not
that's you're cooking too
important.
hard for that. Yeah, Jay would be an amazing TA.
Shameless plugs.
Yeah. But yeah, I think action potential won't be tested too crazy. I would for sure know like the very high yield stuff, how it works, know the chart, know how hyperkalemia affects it, hypokalemia, know the inactivation gates, know like difference between absolute relative refractory, and then the role of the inactivation gates in that. Other than that, that's basically all they would ask. And then yeah, osmosis they covered a lot in first mod, but if you want me to go over each of the situations, I can as well. I can find slides really quick.
I feel like they're gonna test that a lot more in renal, so it probably won't be a huge part of this one.
Yeah, and for the slides, I didn't see any equations for like the muscle one, but the general consensus with that one is physio doesn't care about you doing math except in respiratory. So any equation you see outside of respiratory, I would know generally like what it means, like like what it refers to and how that affects whatever function it's referring to. And then maybe there's general trends, like if the concentration was doubled, how would that affect the equal product? Like would that be halved? Would it be doubled too? Would it be times four if it's squared? So relationships like that are more important than them giving you a bunch of numbers and them saying like calculate what the equilibrium potential is. Like they don't really care about that as much. Any other questions? Oh, and Olivia and Quinn, you guys can head out too. I don't want to take too much of your time just because it started a bit late.
It's okay. I can stay.
Well, you guys are such great TAs. Good work.
Well, I missed the intro because I was grabbing another sausage, so.
A
The fuck
sausage.
fire. I'm gonna look through the slides again too, make sure I didn't miss anything. There's a lot of mumbo jumbo in this slide.
I hate Fisher slides.
I remember I watched one review and I was like, okay, it's not worth it.
The watery baby. That's the only thing I remember.
Yeah, there's a few definition things. You guys can feel free to look at those too. but nothing, they're not like really conceptually anything, it's just terms. But yeah, I think in especially later on, because physio right now is really light. Later on, I would uh put a lot of attention on Costanza and the diagrams in Costanza, especially when it starts ramping up, especially for cardio and renal. That those are very conceptually heavy, especially cardio. Like you have to really be able to understand it beyond just like memorizing this happens, this happens, this happens. So yeah,
The
Costanza
nice
will be
thing
your
about
best friend.
cardio is it all comes down to literally one equation, and if you just understand that equation, that's like all of cardiology.
I'm
Yeah.
But
gonna
it's like
call I'm gonna call bullshit on that, but
You have to just
if you
say, what would
understand
Dr.
if you
Shaw like?
understand how the liquids move, that's it.
fair enough. Do you need to know Titan?
I don't believe
Yes.
so. But actually, the what they have on here, I have it right here. It's just that it's like this little like a little band that keeps the muscles nice and tight so they don't get like loose. Sorry. What were you saying, Olivia?
Oh no. No, that's it. Yeah. I don't think
Yeah.
it's super important to like know a lot about it other than it's really just kind of um holding things in place.
Yeah. And then like part of the importance of it, right? Like if your muscles relax, it's thin and loose. And when you contract it, it has to get like thick, right? It's gonna get thick. So that thickness, you need some kind of security so that it doesn't just like turn into like thick spaghetti everywhere, right? You want to hold it at least somewhat oriented so that when it does contract and needs to be accommodated, the Titan will hold it together. But yeah, I don't really remember it at all. So it's probably not too high yield. Yeah, this random stuff I don't think you have to know here.
Yeah, no, you don't need to know that.
Yeah, this band stuff you should know though. Which one
Yeah.
consists of myosin, which one's actin, what goes away. Yeah, I'm just looking through these one more time. But yeah, I think to be honest for this test, make sure you nail down anatomy though. Anatomy is pretty rough, so if you guys need study tips for anatomy too, we can try to help. But anatomy is one of those classes, it's just grinding. It's a lot more, it's kind of like opposite of physio. You have to just know. Yeah,
I liked Visible Body a lot. I thought that it was really helpful.
I'm gonna just speak from my personal experience of visible body's good, definitely for like Olivia said, for the practical. For like anatomy in general, like I know like a lot of people hate it, but like Anki, like and just brute forcing slamming yourself every day with just information over and over again in the form of a flashcard works extremely well for something that is a class that is just memory driven.
I
yeah.
think
Like
But
it
especially
just makes your life so much easier.
for
for
this
me to be
one
devil's advocate, oh
particularly,
sorry.
no, like have the brachial plexus memorized, draw it out before the like what's